Hello and welcome back to PA Academy. This is a part 2D of the video series under permutation. So right here what you are dealing with is arrangements without repetition. So in other words, that repetition is not allowed. So they are saying the same thing. You can find some material with right arrangement without repetition, and some might write repetition is not allowed. But what we are still saying is the same thing. So if you missed the previous part of this video, you'll find the link in the description of this video. And here is the formula to use when you are dealing with arrangement without repetition. N permutation R is equals to n factorial over into brackets n minus r factorial. So the meaning of our r of our n is the total number of objects. That is the total number of objects to be arranged. Why r is what? The total number of objects to be arranged. This one is the total number. Why this one is that part of the total number from that the number that needs to be arranged. So now let's look at this example 1. It says, in how many ways can 5 out of 15 students be arranged? So that means if you have 15 students and you want to arrange 5 out of that 15 students, how many ways can they be arranged? So let's do that. So this is the formula n permutation R. So let's find the value of our n. Our n, which is total number of objects. The total number of objects in this question is what? Is 15. And our r, which is the number of objects to be arranged. In how many ways can 5 out of 15? So that means it's 5 that want to be arranged. Is 5. So let's put it in the notation. So that will be 5. No. So n permutation R, our n is 15, so that will be 15 permutation 5. That will be, so n factorial, our n is 15, so that will be 15 factorial over, so here n minus r, now that will be 15 minus 5, 15 minus 5 factorial, so that will give us 15 factorial over, so 15 minus 5, that's 10 factorial. So let's simplify this. Let's continue from this point. So 15 factorial over 10 factorial, that will be written as 15 times 14 times 13 times 12 times 11 times 10 factorial. So we can stop at 10 factorial because the denominator here we are having 10 factorial over 10 factorial. So we can just write this as 10 factorial because we also have 10 factorial at the numerator, so they can cancel out. So what you are left with is 15 times 14 times 13 times 12 and times 11. So multiply that in your calculator. So once we do that, we'll be arrive at 360,360 then ways. So that's the solution to question number to the first example. It says, in how many ways can 5 out of 15 students be arranged? So so they can be arranged in 360,360 ways. Don't forget, the question is asking us in how many ways. So once we get the value, we should add ways to it. And then let me come back to this factorial. If you decide to continue writing 10, like 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 till we get to 1. We're also going to do the same thing to the denominator. That's 10 times 9 times 8. So instead of going through, taking all the whole space or the time, you can just stop at 10 factorial because we know that we are still going to have 10 factorial at the denominator. So they can cancel out. So that is it for example 1. So let's look at another example. So example 2 says, in how many ways can 3 vacant places on a bookshelf be filled if 7 different books are available? So let's do this. So let's bring out our values. In how many ways can 3 vacant? So that means our R is 3. That's the number of objects to be arranged. Can 3 vacant places in a bookshelf be filled if 7 different books are available? Then our N is 7. So let's put it, the formula is n permutation R is equals to n factorial over n minus r in brackets and factorial. So let's put in the right values. So n permutation r, our n is 7 and our r is 3. So that will be 7 permutation 3. That will give us 7 factorial, then n minus r over, that will be 7 minus 3 factorial. So that will give us 7 factorial over 7 minus 3, that's 4 factorial. So that will be 7 times 6 times 5 times 4 factorial, all over 4 factorial. So at this junction, 4 factorial can cancel out 4 factorial. I believe by now you should know why I stopped at 4 factorial, because at the, in the denominator we are having 4 factorial here, so we can also stop at 4 factorial because they can cancel out. So if you multiply 7 times 6 times 5, so 7 times 6 times 5, so let me use this small space because of our space. 7 times 6 times 5, that's 210. So the answer to example 2 is 210 ways. So that means 3 vacant places on a bookshelf. In how many ways can 3 vacant places on a bookshelf be filled if 7 different books are available? That's 210 ways. So that is it for this part of this video. In the next part, we are going to be looking at more examples under arrangements with repetition. Please, if you are yet to subscribe to this channel, kindly click on the subscribe button. If you love this video, kindly give it a thumbs up and click on the share button to share this video. And I'll see you in the next part of this video. Thank you.